Have you ever thought, why does a YouTube video get 100 views, then maybe 200, and then maybe 500, and suddenly 1 million? So, why doesn't it grow at the same speed the whole time? Today, you'll see that one simple idea from calculus that explains YouTube growth, population growth, bacteria, compound interest, radioactive decay, and even how medicines leaves your body. So what exactly makes something grow? Can you answer that? Maybe most people say time. Not exactly. So imagine two YouTube channels. One has 100 subscribers, the other one has 1 million subscribers. Suppose both upload an equally good video, or if both channels grow by 10% this month, what would you say? Which channels or which subscriber channel gonna get more views on the first video? The answer, you probably gonna answer the million subscriber channel, correct? Why? Because more views means more shares, and that's gonna conclude into more viewers as well. So exactly, the growth depends on how many viewers you already have, correct? That is the entire idea behind exponential growth. This is the key. For example, let's take a look at the graph real quick. What do we mean by this? That the growth depends on how many viewers or how much you already have. If you look at the graph, this is okay. Okay, you assume, right? This is passing through here, the region. This is y is equal to x. And then here is the y is equal to e raised to power x. Notice something interesting here? Exponential growth, this exponential function, does not start fast, right? It starts slower than you might expect. But because it keeps growing by a percentage instead of a fixed amount, like, it eventually leaves linear growth far behind. And this isn't just a YouTube story. If you look at the other problems, for example, population means more people and then means more births. Same thing, bacteria. This is we already have, right? And this is growth. More bacteria, more cell division, right? Radioactive decay, more atoms means more decay. So in every case, the rate of change depends on the amount that currently exists. So how do mathematicians write the sentence? What we just saying that the rate of growth depends on the current amount, what you already have. Like for example, YouTube, it's gonna grow based on what or how many subscribers I already have. If I have 100 subscribers, it's not gonna grow that fast in comparison to a channel with million subscriber. So the mathematicians in calculus, we say this as this dy over dt is directly proportional to y. The rate of change derivative is proportional to the amount you already have, or the rate of growth. So in general, this is the definition. If yt is the value of a quantity y at time t, and if the rate of change of y with respect to t is proportional to its size y of t at any time, then dy over dt is equal to k times y, where k is constant and if k is greater than 0, that means more bursts, more cell divisions, etc. It's called a law of net normal law of natural growth. And if k is less than 0, negative, more atoms means more decay, right? So it's also called law of natural decay. And this is called a differential equation because it involves an unknown function y and its derivative. Now, do you have a question? Now, would you think little more which function has a special property that its rate of change is proportional to itself, or derivative is a constant multiple of itself? Can you think of? Pretty sure majority of you have guessed already. It's the exponential function, right? The derivative of natural exponential function is stays the same, e to the x. So we have exponential function of form c times e raised to the power k times t, where c is a constant. So now that you understand the idea, you'll start seeing the same equation everywhere in finance, biology, chemistry, or physics. And we have this theorem that the only solution of this differential equation dy over dt is equal to constant k times y are the exponential functions, which is this function y of t is equal to y, what we initially have, and how it grows or decay. And this is what the topic is all about: exponential growth and decay. So at first, YouTube views, population growth, bacteria, investments, and radioactive decay seems like completely different problems, correct? But calculus sees something deeper. It ignores the story and asks just one question. Does the rate of change depend on the current amount? So always ask when you see a word problem, does the rate of change depends on the current amount or what you already have? If the answer is yes, so you have entered the world of exponential growth and decay. I hope this conveys the idea and it helps to understand better. And forgive me if I did not convey or explain this clearly. Thanks for watching.